the content video competition. So stay tuned on our social media platforms to keep up to date with these amazing events. Now that I've introduced us, let's take this opportunity to also introduce our collaborators for this workshop series. To introduce the IEEE Robotics and Automation Society of the Wellassa University, I'd like to call up Tusita. Over to you. Tusita, when you're ready, please go ahead and introduce the IEEE Robotics and Automation Society of Wellassa University.
Yes, a very good evening. Yes, and sorry for the interruption. Yes, good evening, and hope you all will be engaging in a very productive session on robotics, which is commencing this week onwards. So as to begin, we are the Robotics and Automation Society of Wellassa University, Badulla. As the first entrepreneurial university, Wellassa educates students with an emphasis on entrepreneurship and employers' demands. Under the IEEE student branch of Wellassa University, Robotics and Automation Society is with the mission of connecting the international platform with the global technology community and the technological professors universally through the means of robotics and new technologies related to it. This student branch runs with its executive members for the second time as it made its move 2 years ago. The advisors of this chapter have always been guiding the inside story to enlighten this student branch. Many workshops have been conducted around the topic of robotics to enrich the knowledge of undergraduates and also school students who are hoping to set foot on the field of robotics tomorrow. And hope you all will be engaging in a very interactive session today. Thank you, and over to you, Anjali.
Thanks, Tusita. Next up, we have Circuit Breaker Robotics. Circuit Breaker Robotics is an edutech startup envisioned in empowering the next generation to Industry 4.0. The latest initiative, Little Engineer Academy, is a STEM academy for kids from age 10 to 18 to study engineering tech-related fields at any time, any place, and at their own pace, while getting a one-to-one mentoring from tutors. The programs are fun and addictive, including competitions taught by engineers and mentored by university undergraduates. To introduce Circuit Breaker Robotics, we have a quick video.
Circuit Breakers Robotics is the #1 platform for robotics in Sri Lanka. Education is the most powerful tool which you can use to make the world a better place. Our vision is to empower robotics education in Sri Lanka. Quality and effective education is needed to produce a wiser young generation. With this in mind, our mission is to provide educational content and related services to uplift the robotics enthusiasm among Sri Lankan youth. Circuit Breakers education is one of our biggest pillars. We have organized more than 20 island-wide workshops and webinars for undergraduates and school students. Our impact is widened with the partnership of many recognized non-profit organizations in Sri Lanka. Through these sessions, we have empowered thousands of students about robotics and innovation. It's always heart-touching to see moments where students build their first robots with enthusiasm and unwavering desire. We are running our lives in the midst of an unprecedented pandemic, which made a huge impact on our society and the education system. We at Circuit Breakers, driven by innovation and creativity, our young engineers have found creative, innovative, and mind-blowing ways to educate kids through online activities. Furthermore, we are the initiators of building the largest and active community for robotics in Sri Lanka. Robotics enthusiasts and experts have joined together to share knowledge and experience through our community on Facebook. Our latest initiative for kids, The Little Engineer, is a premium program targeted to the young innovators from age 10 to 15 to lay a strong foundation about programming, designing, manufacturing, and soft skills, which are essential for creativity and innovation. Latest technologies such as robotics and the Internet of Things are used in collaboration with STEM learning techniques. Education is not meant to be bored. Our sessions include mind games, lab sessions, and beautifully crafted materials to make education enjoyable. The strength of Circuit Breakers Robotics is the team behind it. Our leadership consists of all-around multidisciplinary engineers who have excelled in academics and extracurricular work at both the university and school level. Every circuit breaker is enthusiastic to learn the latest technology, apply them in real world, and most importantly, empower the community from the experience and the knowledge gained. We at Circuit Breakers have won many robotics competitions internationally and locally, which equips us with the strength and capability to educate the next generation of innovators. Sri Lanka needs lots of creative innovations to prepare for the future. When we empower the next generation with technology, skills, and core values, it's a matter of fact about the possibilities they will unlock in the future. Circuit Breakers Robotics. Learn, apply, empower.
So that's all for our collaborators for this workshop series. Moving on, keep in mind that if you attend all of the sessions conducted for this series and fill in our feedback forms, you will receive a certificate of participation. We also have a Kahoot session lined up for you after the main session, so stay on your toes. If you have any questions during the presentation, please feel free to type them into the Slido link, and I'll be bringing them up during the Q&A session, which will be conducted later. Now, I would like to welcome our speakers for today's event. Chamindu Liyanage from the Department of Electronic and Telecommunication Engineering, University of Moratuwa, and Duvishka Kavin from the Department of Mechanical Engineering, University of Moratuwa. We're deeply honored and privileged to have you up with us here today. With that, let me invite today's speakers to take the virtual stage and start you off on this journey of robotics. Over to you guys.
Yes, thank you, Anjali. Mava,
Yes, we can hear you.
Okay. සියලු දෙනාටම සුබ සන්ධ්‍යාවක් කියලා පිළිගන්නවා. Circuit breakers වෙනුවෙන් මම චමිදු ලියනගේ. ඉතින් අපි වැඩි වෙලා ගන්නේ නැතුව අපි අද session එක start කරමු. අද session එකේ main topic එක වෙන්නේ introduction to robotics. ඒ කියන්නේ robotics කියන්නේ මොකක්ද කියන එක ගැන ඔයාලට ජෙනරල් අයිඩියා එකක් වගේම අපි සෙන්සර්ස් කීපයක් ගැන අයිඩියා එකක් අද පළවෙනි සෙෂන් එකේදී දෙනවා. ඊට පස්සේ ඉදිරි සෙෂන් වලදී ඔයාලට සෙන්සර්ස් ඇක්චුේටර්ස් සහ ඊට පස්සේ රොබෝ කෙනෙක් හදන්නේ කොහොමද කියන ඒවා ගැන අයිඩියා එකක් ගන්න පුළුවන් වෙයි. ඉතින් මුලින්ම robotics ගැන කතා කරන කලින් අපි මේ content එක ගැන අපි කවුද කියලා මුලින්ම ඔයාලට හඳුන්වලා දෙන්නම්. කවුද circuit breakers ලා කියන්නේ? කවුද circuit breakers ලා කියන්නේ? එතකොට අපේ ටීම් එකෙන් කරපු නැත්නම් හදපු robots ලා කීප දෙනෙක් තමයි ඔයාලට දැන් මේ slide එකේ පේන්නේ ඉන්නේ. එතකොට විවිධ competition වලට විවිධ අවුරුදු වලට හදපු robots ලා කීපයක් තමයි ඔයාලට slide එකේ පේන්න තියෙන්නේ. ඉතින් අපේ ස්ටෝරි එක පටන් ගන්නේ 2017 දී. 2017 දී අපේ CEO දීපන් අයියා robotics competition එකකට ටීම් එකක් දාද්දි හදපු නමක් තමයි circuit breakers කියන්නේ. එතකොට ඒ ටීම් එක robotic competition එකට දාන්න හදපු ටීම් එක circuit breakers. ඒක අවුරුදු ගාණක් යද්දි විවිධ මට විනාඩියක් දෙන්න. Yeah, sorry for the delay, guys. So I just received a message from one of you that to do the session in English. So I will be doing the session both in English and Sinhala. So unfortunately, I can't speak Tamil, so therefore I will be only doing the session in two languages. So as I was saying, I was telling our story. So we started at 2017 with our CEO Deepan Ayya. So he started Circuit Breakers Robotics as a team who has registered for robotics competition. Then after during the 3 or 4 years, we have competed in several robotic competitions such as SLRC, then RoboFest, like that. And in many cases, we have come to first 3 places in those events. So then at around 2019, we have competed for around 9 competitions, and we have developed 9 robots at that stage, different robots. And then our Circuit Breakers community, so we have initiated the Circuit Breakers Society at 2019. So that's where we have started to give webinar series and other educational stuff. And in 2020, we have started CBSL, CB3D, and CB community. So that's our journey so far, and it's many more to come in the future. So okay, can someone confirm whether the sound is audible?
Yes, the sound is audible.
Okay, so this is a video from 2019 SLRC. Let's watch it. Yeah, that's the competition. So the full video is out on YouTube. You can go to our YouTube channel and watch the video. So let me give a brief explanation on that task. So we had to build two robots. I mean, it's not necessary to build two robots. You basically had to build an arm and a robot. So our team has built two robots, and one robot has to navigate through that grid. And I think you have seen that we have to put a coin in one of those colored boxes, 3 coins actually, and then navigate through color patches and like that. So in that year, we have become the first runner-up, and also we got the award for best robot design. So as I mentioned earlier, you can see the video in our YouTube channel. So what is our vision and mission? So our vision is to empower robotics education in Sri Lanka. As you know, in Sri Lanka currently robotics doesn't have much of a place, especially in school education. So our vision is to empower robotics education and uplift it. And our mission is to provide free educational content like this webinar series, and related services to uplift robotics enthusiasm among Sri Lankan youth. So we are currently working on that. As you can see, we are providing free seminars for you guys as well always. So, as well as we are providing some paid contents. So then what is CB community? As a CB community, so it contains both our team as well as the people outside the CB, and they have gathered to empower the robotics. So you can see from the links, you can go to our Facebook group and join with our community to uplift the robotics education. So as a community, we are conducting free workshops like this, and we have conducted free workshops, many more free workshops in the recent years. So I personally have participated in many workshops online, both as well as physical workshops. And then we provide free educational content. So if you go to our YouTube channel, you can see so many tutorials about PCB designing, robot designing, so on and so forth. So those are the things that we do as a CB community. As I said earlier, you can go to these links and you can follow us on Facebook, and you can follow us on Facebook, YouTube, LinkedIn, and Instagram. So what are our services? So we provide 3D printing, 3D designing, and PCB designing services. So if you want to print anything, print any 3D structure, you can contact us. And also if you want to design something, you can also contact us. And also if you want to design a PCB for your electronic device also, you can contact us. Yes, I will send those YouTube link after my session. Then these are some of our 3D models we have done. So this is done for, I think all of you know Vega Industries, right? So it is Sri Lanka's one of the main technological companies. So our head of designing, Ramita, has done this design for Vega. And this is a 3D model. We also it is done by Ramita. So he has done this for our premium content little engineer, as you have seen in the previous video. So those kind of talented people are with us, and you can in 3D designing, you can contact us. And this is a 3D micro mouse. I don't know how many of you know about micro mouse. So micro mouse is basically a maze solving robot. So for that, our team has designed a custom PCB. So it is in the screen. And also these are some of our 3D models that have developed. So that's all about us. So as I said earlier, I will send all the links to Zoom chat after my session. So let's go on to our main topic. Why this is an important opportunity for you. So first of all, as I said earlier, there are no robotics related subjects in our school curriculum at now. Okay, so the most recent technologies that you can learn is IT and electronics. Electronics are also only theoretical parts you can learn, not practical aspects. So from this seminar series, this will be a base for you to learn about robotics, and you can decide your future path with this, with the knowledge you gather, and also you can practically apply what you have learned. As I mentioned earlier, we learn electronics only theory parts. So when you build a robot, you have to know about the theory thoroughly, and as well as you should know how to apply that theory to realize the design. So that knowledge also you can gather from our seminar. And also the most important part, I think, effective use of your free time. Just think about how much free time you have. Especially after A-level students, you have a lot of free time. So you can use this free time to enhance your knowledge on robotics. Then, so what is robotics? That's the first question that we should ask when we come to robotics field. So what is robotics actually? How this robotics word has formed? Robotics කියන වචනය හැදිලා තියෙනවා. So robotics or robot has formed from the old word robota. Anyone know the meaning of that? Robota. Okay, so robota is basically forced labor. So that means we force something to do some labor for us. In the old times, slaves have been used for such thing, but now we give a robot such name because we tell the robot what to do, and we use robots to our day-to-day life advantage. So that's how robot word has formed. So robotics, when you say robotics, what are the fields that is associated with it? So robotics is a collection of mainly 3 fields. Those are electronics, programming, and mechanics. So electronics is important because we use all kinds of electronic devices in our design, such as let's say transistors, then diodes, and then microcontrollers. Those all kinds of things are electronic devices. So we need a thorough understanding of electronics. And then programming. To tell a robot what to do, we need to program the robot in a correct manner. So also we need a thorough understanding of programming. It might be Arduino, it might be C++, it might be Python. So you need to have a proper understanding of programming, and you should know how to apply it. I mean, you should know how to program a robot. And then the last part is mechanics. Like I think you have seen a robot arm. So in a robot arm, you should know how to control the servers so that a robot. How do you play? How do you like place some object? Like if you lift some object and place it in another place, how do you like calculate such things? So for that, you need mechanics knowledge. So those three fields are essential in when you learn about robotics. And then let's move on to a formal definition. A robot is a device which can be programmed to cater different functions which with minimal changes externally. That means if you use a design, you can like let's think of it as a human. So without changing your appearance or without changing the place your arms and legs are, I can tell you to run, I can tell you to walk. So as like I can tell you many actions to do. So like that, a robot is a device where without changing many hardware, I can tell it to do some task, some specific task. Sure, it has some limitations according to the hardware, but I can tell several tasks. I can tell it to do several tasks. So that's the formal definition of robot. Okay, then we categorize robots into mainly two categories. Those are industrial and consumer. So what is industrial robot and what is a consumer robot? An industrial robot is, as the name suggests, it is used in industry. Like as you can see, there are like several robot arms shown in this slide. So this is KUKA, and this is the the picture that I'm showing. It's from Amazon warehouse. I think you all heard of Amazon. So in Amazon warehouses, these kinds of robots are used to transform packages within the warehouse. As you know, the Amazon warehouse is pretty much big. So for if you use human labor, then it will take so much time to put one box into another place and so on and so forth. So if you use a robot instead of a human, humans get tired. Humans need to sleep. Like that, humans have many restrictions, but a robot can work 24 hours a day without getting tired. So Amazon has used, I believe, near 200,000 robots for the management of these warehouses. And this is a robot which is used in Tesla company. I believe you also know about Tesla. So this robot is helping to assemble the car and put it in one place to another. So those kinds of large scale robots are used in industry. And what is a consumer robot? So consumer robot is what we use in a day-to-day life. So can I get a like how many of you know this robot? Can I get a raise hand if you know this robot? Sorry. Okay, this robot. Okay, seems like not many people are. Yeah, okay. So as a robot enthusiast, you should know about this robot. Okay, so this is DSN, the first ever humanoid robot manufactured in Sri Lanka. Completely manufactured and assembled in Sri Lanka. It is manufactured by a company called Arimac. So remember that this is the first ever humanoid robot manufactured in Sri Lanka. And also, this is a robot that we call, this is actually a vacuum robot. I mean, a cleaning robot. So this robot's name is Roomba. So it cleans households, and so also the special ability of this is it can detect obstacles and avoid it. So in your living room, you don't need to control it by manually. I mean, you don't need to control it by using a controller or such that. It can detect obstacles in the way, and so it can detect obstacles in the way, and it can avoid those obstacles and clean your house. And this is what we call a vector robot, and this is the spot robot, which is manufactured by Boston Dynamics Robotics company. So Boston Dynamics is also a major company, major robotics company, and it has made this kind of legged robots. And let's see those robots. So this is inside the Tesla company. As you can see, all the assembles are done using robots. Some parts are done using human hands, but most of the assembling part is done using robots. As you can see, some parts should be done by hand. And this is what they call the Iceman. So it's pretty huge, as you can see. That's the industrial robot, and let's see about Spot robot. This is manufactured by Boston Dynamics. So it's a legged robot. I don't know, like it's pretty much hard to, I mean, pretty much complex to build such legged robots because you have to like think about the stability. So it has several functions which adds to complexity. Another external arm can be attached to the robot, so it can do some other tasks. It can carry weight. So yeah, if you search Spot on internet, you can find many more things about the robots. Okay, so what is the future potential of robotics? There are many future potentials in robotics. I can let's like mainly focus on three aspects. The first aspect is it has the focus on automation and Internet of Things. So automation is basically what we build robots to do what humans do. Like if you do a repetitive task, people try to build a robot to do such tasks without humans. such as assembling this kind of parts, packaging like that. So, and also now researchers also try to add Internet of Things to robotics. It's already like added in several ways, but they try to maximize the potential. So Internet of Things is what Internet of Things is. It can communicate. A device can we can make a device such that it can communicate with internet, and it can take several actions. So such as, let's say, a smart TV. So smart TV can we can broadcast our cell phone and our smartphone screen to smart TV. Like that, there are several options. Yes. So with these two technologies, we can build even more complex robots in the future. Also, you can build human-centered and collaborative robots. That means you can control a robot either by using a controller or either by capturing hand movements. As you can see here, this person's hand movement is captured by this robot. And here there is a control panel to control the robot. And here, this is a special one. So doctors will be able to do remote operations using 5G in the future. So that means the doctor is not necessary to be in the theater when he want to do a surgery. So that's a huge leap in medicine industry. So robotics is not just about robotics, it impacts all the world, okay, all over the world. So therefore, this is a vast industry. Then let's see another word.
For more than 85 years, Omron has helped perfect the art of building machines that help humans. Now, we introduce a machine specifically built to work with people. Meet the Omron TM Collaborative Robot Series. This is a robot designed with a singular vision, human and machine, working together in perfect harmony. A robot so versatile, it adapts to any number of tasks. Guided by a state-of-the-art robot vision system designed to recognize a reference point, the robot can be moved and perform its tasks with no additional setup.
Let's move on to another video.
Could this
So
be
the previous robot was designed to like pick and place things in with precision. As you know, as humans, we can't place some object with precision, but using a robot, we can like excel in precision side. So here now this robot is a robot that is used to work in a shop. So let's see.
Could this be the beginning of mass retail automation? In August, this Japanese kangaroo robot will arrive for work at a convenience store to stack sandwiches, drinks and ready meals on shelves. If the experiment succeeds, retailer Family Mart says it will employ more robot workers at 20 stores around Tokyo by 2022. The robots will be operated remotely by people until the artificial intelligence has learnt to mimic workers, according to Telexistence CEO Jin Tamioka.
The humans is manipulating the robot to do.
Okay, so if you have listened in the previous video, it says that that robot is used to store goods in the shelves of the store. So it says at first it will mimic human, like humans has to give the input and human has to control the robot at first, but then using artificial intelligence, I think you have also heard that. Using artificial intelligence, we can like make those robots to work on its own. without human assistance. So this is remote operation. Let's watch that also.
其实5G呢，就是让我们可以做到在很多场合，比如说救灾的场合，还有一些像
So in that video, the doctor specialist says that like the most important thing in that video is that give me a minute. Sorry for that. So the most important thing that was mentioned in the video is that the speed of the communication. So if like think that when you are doing a surgery, if there's a lag, so then it will be a problem, right? And to overcome that, they have used 5G technology to do such operations so that they can minimize the time between the input and the output. So that's all about the robots which are built and used in our everyday environment. So some of them are in the like research stage, some are in the commercial stage. So that's how robotics is evolving. And let's see what we can learn from this webinar series. So first you will understand how robots is a world. So and then you will understand how robots interact with the world, and then finally you will get to know how to make a robot. So before talking about robots, let's talk about humans. How do we sense the environment? We sense the environment using 5 senses. As you know, sight, hearing, taste, smell, and touch. Those are the 5 senses that we use to take inputs from the environment. So like that, robots also have what we call sensors to sense the environment. As you can see, robot observes the environment also itself using its sensors. So to give you an example, just think that you have got a fever. So how do you feel it? So you feel that inside your body, the temperature is heating. So that's something that you have got from your inside. And also if you see something like here you see your I think laptop screen or something, and you see these words. So that's the external input. And so also robot can observe both the environment and itself using sensors. Then it can make decisions. So how do they make decisions? That's by using microcontrollers or computers. And then finally, after making the decision, they can put it into action. So that's how robots sees the world and interact with the world. So to see the world, to sense the world, robot use robot sensors. As I mentioned earlier, to know about the inside or to know about their internal state, robot uses proprioceptive sensors. Okay, proprioceptive sensors, or we can say internal sensors. So the internal sensors, some of the internal sensors we use are optical encoder, accelerometer, and angle sensors. So using optical encoder, we can measure the distance the robot has traveled as well as the speed the robot is traveling. So that's the internal measurement, right? Because the speed of the robot is something which is embedded to the robot itself. And also accelerometer measures the acceleration. Also angle sensors measure the angle inclined referring to the base. And then there are also exteroceptive or external sensors. Those are used to sense the external environment, such as we can use cameras to see the site in front of the robot, and then we can use range sensors such as ultrasonic, time of flight, laser, IR, LIDAR sensors to see whether there is an obstacle in the way, and then we have contact and proximity sensors such as IR detectors, then PIR motion sensors. This is a PIR sensor, and then touch sensors, and then temperature sensors to measure the temperature outside. And this is only a small list. There are so many sensors that you can use to sense the environment. So it will depend on your application. Okay, so in the due weeks, we will learn about ultrasonic sensors, push buttons, deep switch, and potentiometers. So you can learn them maybe on next week or maybe tomorrow. So that's how the robot sees the world. Then how robot interacts with the world. That means if the robot sees an obstacle using sensors, then it takes a decision to avoid the obstacle and go past it. So the action that have taken is avoiding that obstacle by changing its direction and going through that change direction. So that's the action. That's the interaction that robot has taken. So to perform such tasks, robot use actuators. To sense the world, it uses sensors, and to perform such tasks, it uses actuators. So actuators are the output devices used by the robot to perform actions as decided by the robot brain. Okay. Then the most common actuators that we use is motors. We use to move the robot, we use motors. So that is one of the most common actuators that we use. Then these are some actuators, like we have DC metal gear motor, then servo motor, then hobby gear motor. Now this is most commonly available. If you have built a robot, then you probably have used this motor. And then there's vibration motor and even LED. So LED is considered as an actuator. Why? Because it can emit a light, right? So if imagine we want to build a robot where if obstacle is near us, we need to flash the light. So then the LED is the actuator. So it flashes the light. So it outputs something. So therefore, we can consider LED as an actuator. Also, we can say LCD screens and OLED screens are also actuators. Then speaker, buzzer is actuator, like that. Then let's see a simple robot. Even you even a beginner can build such robots. So this is a good video for beginners.
Viral Science, the home of creativity.
Hey friends, welcome back to another video. Today I will show you a obstacle avoiding robo. Previously I have made obstacle avoiding cars, but this is slightly different with the components and the code. For this I will be using L29 3D motor driver shield, and previously I used L29 A10 motor driver module. So let's get started making this.
So I'm not going to play the full video. You can see that on YouTube. So what this robot basically does, see it has this head kind of part. So it senses anything which is any obstacles which is near. So you can see when the speaker put her hands in front of the sensor, it detects that and that's the way, and it changes the direction. So that is what obstacle avoiding robot does. So if you want to build such robots, you can always go to YouTube or internet and find many instructions in the both in YouTube and internet, especially in Arduino forums. Like they have discussed so many what we call so many projects in those forums. So I also encourage you to go to those forums and look at them. Then okay, so that's all about introduction to robotics. And from this point onwards, we will discuss about theory. So we will first discuss about breadboards and LEDs and their importance in robotics. So to conduct the session, I invite my colleague Vishka to continue. And if you have any questions, please put that in Slido. I will be staying until the session, and I stay until the session is over, and I will answer your questions. Yes, thank you.
Okay. Let me share my screen. Can you see my screen, and am I audible enough?
We can see, yeah.
Yeah. Okay. As Chamit mentioned earlier, we need basic knowledge about electronics programming and those kind of things to build robots. So today we are going to get some basic theories about breadboards and LEDs. So let's get started with breadboards. What is a breadboard? I think most of you have used breadboards in your projects. This is like a circuit actually. This has connected rows and columns. We can build our circuit very easily using this kind of boards. Let me, I think you can see my pointer. This is a normal size breadboard, and here you can see these red line and blue lines. These are connected through this row. If you apply some power into this pin, you can get output power from this pin. As well as there are rows connected in black lines. These rows are connected in this way. I think you can see these things. So breadboards are mostly used to demonstrate, build up prototypes. It can be used easily to build prototypes. I think you can see this image. This is a simple circuit that power up a LED. You can easily use breadboards to build up these kind of circuits. So I think you have an idea about these things. Let's move on to LEDs. And LED, I think most of you have done your A-levels and you know about theory behind LEDs. This is a diode which contains different materials, and this is a symbol of LED, and this is the actual image. I think this is the actual image of LED. LED has a anode and cathode. This is only difference from a usual bulb. This connects only actually you cannot connect in both ways. This not allows to pass the current in both ways, only in one direction. So I will explain a little bit more about in next slide. So this is a RGB LED. I think you have seen this. This LED can use as a like a combination of 3 LEDs. Like if you want to use red LED, you just want to you just need to give the signal to red and the cathode. So likewise, you can use these things in your projects. And this is a SMD type LEDs. I think this is quite new to you. So SMD means surface mounted device. So these LEDs mostly used in PCBs. PCBs means printed circuit boards. This is very small in size, so we can use in compact our circuits to minimize the size of the circuits. Most of printed circuit boards use this type of LEDs to their functionalities. I think you have seen these things in day-to-day life, but you don't. So when talking about LEDs, you need to know about their VI curves. This is the voltage and the current curve. You have learned this in O levels, I think. You can see there's for red, green, and blues are three different types of curves. I think you know the reason why there is three type of curves. Because of the material used in the diode, the characteristic curve differ from each other. So if you apply 1 point, as example 1.5 volt to the red LED, it will light up, but in most cases blue LEDs will not light up much. You can experience this in our practical session. So in order to determine which voltage is suitable for each LEDs, you need to follow up these LED characteristic curves. So and you have experienced something like if you give 5 volt or directly connected to 9 volt to LED, the LED will burn up. So that is the reason you can see in this curve. If you exceed like 1.7 or 1.8, almost 2 volt, there is a huge current through the LED that will cause to the end of the LED, like burning it, and you cannot reuse it. So when you're dealing with LEDs, the most important thing is the current. You need to put some resistors and reduce the current through these LEDs to work with. So there's a simple circuit, LED circuit. Just simple calculation for this LED. The LED is operating at 2.5 and 10 milliampere. So what is the resistor we need to apply? I mentioned earlier, we mostly use resistors when dealing with LEDs. So you have to calculate this resistor value. So otherwise, if you're using a large resistor, you will not get the proper light emission, or otherwise LED will burn. So in this case, you can see the source voltage is 5 volt, then LED keeps 2.5 volt, then the rest of voltage is in across this resistor. So you can calculate the resistance value according to the given current. I think you all know V equals IR. So that's all about LED. So you can learn with, if you interested in these things, you can learn through online. I will guide you with some examples. So this is the first thing. I think you in your mind in this session. I mean, like how to make a robot. In previous videos, you saw that line following robots and human obstacle avoiding robots and human following robots, such kind of things. So I think you have interested in this building this type of robots. So how to start building a robot? So I will give some steps to build a robot. So first thing, as mentioned in first slides, you need to have basic theoretical knowledge about electronics, programming, and such kind of mechanics, and such kind of things. So you have to learn these theories as well. So first thing, the best way to build a robot is gather up a team with or with your friends or with your colleagues. Then brainstorm your ideas with them and discuss them with select the best option available. What are the sensors you are going to use? What are the functionalities the robot needs? So likewise, you need to select the most suitable sensors, microcontrollers. Likewise, you need to select those things. Secondly, most of times we go to simulations. Simulations mean we can run our physical environment in a virtual space. So today we are going to use such kind of application named Tinkercad. I will explain a little bit about it later. So in simulations, you can you can see what's going on if we use these sensors, if you use these actuators, what is actually happening in this type of situations. So simulations is most simulations are done in most cases because it's very cost effective and you can choose what is the best options for the robot. So after the simulation, we go to the prototypes. Prototypes are the starting circuit. Likewise, you just plug these wires and use breadboards. Sometimes use breadboards and use LEDs and just create a simple circuit and try if it is working or not. And after the prototype, you can build your robot. You can buy components and you can build the most suitable way. So that is the process of how to make a robot. Then I mentioned earlier about the knowledge. You need basic knowledge about robotics, I mean electronics, programming, mechanics, and such kind of things. So how we learn these things? Can we learn these things in school? Yeah, we can learn, but there's limitations. In A-level syllabus, you can learn electronics, but there's limitations. There's limitations. So can we learn these things in tuition classes? I think it's not possible. So the best way to learn these things is online. You can use YouTube or other premium. These are premium platforms that provide various type of courses from different universities. So the best way is YouTube. This is easy and most cost effective. And if you are going furthermore, you can select courses from these Udemy, Coursera, LinkedIn Learning, like in these sites, you can choose your course and continue your studies. So just search about these in internet and get familiarized with these websites. So you will see what are the available courses in these platforms. So I mentioned earlier, we are using Tinkercad for this session. So what is Tinkercad? Tinkercad is a simulation software by Autodesk company. This is a famous company that provides a lot of simulation softwares. So this is why we choose Tinkercad. There's several benefits for being using Tinkercad. First one is this is a freely available open source software and no need of installations. You can just go to this link and you can start your project. And next thing is this is not much complex. No need of much knowledge about this software. You can just go and see what's inside and start your projects today. So let me sorry. Can you see this screen? Can someone confirm?
We can.
Yes.
Yeah.
This is the interface of Tinkercad software. You can see there's different options and login and sign. So first we need to create an account. For that I will share another video. This video is about creating an account in Tinkercad. I will share this video after the session and you can watch it now.
This video is a complete tutorial in creating an account in Tinkercad. Furthermore, we will be covering the basics of making your own electronic simulation. First, visit the official website of Tinkercad through the following link. The link will also be available in the video description. Click the Join In button at the top right corner of the screen. Click the link which says Sign In the next screen. You may sign in to Tinkercad by your Google account or your Apple account. For that, click the Preferred button and select your account. You can easily log into the dashboard this way. Also, you may create your own account at the Tinkercad website. For that, click the Create a Personal Account button in this page. Now click the Sign Up with Email button. Select your country and date of birth and then click Next. Type in your email address and the password you wish to use with your Tinkercad account in this page. After checking the checkbox, click Create Account. Click Done. You may use these credentials to log into your Tinkercad account at any time again. Now let us have a brief idea about creating a simple electronic simulation in Tinkercad. After logging into your account, visit the Circuits tab by clicking this button. Click Create New Circuit.
Let's get started. This is the interface you can see when you are logged into account. I will share the video after this session. So in here you can see there are 3D designs and circuits and this code blocks, and we are using these two in our cases. Tinkercad allows you to design 3D elements in here. This is a simple software, but not much functionalities available, but this you can start with this. Today's session we are going to build up a simple circuit. So for that, press the new button and you can select circuit. When you are selecting circuit, you will get this type of window. I think you can see this. This is the software interface, and I will explain one by one what is the functionalities of these things. Yeah, this here this is a small toolbar, and this is start simulation button, and this is a we can code these things. This is the component list, and you can see there are so many components in this. So first of all, I'm just using breadboard. Okay, you can just search breadboard door. You will find this in basic components. Here, this is a breadboard is small, and other type of breadboards are available in here. You can zoom in and zoom out using your scroll, and you can drag these things by click and drag. And yeah, these are the basic functions. So I'm using a small one. As I mentioned earlier, can you see this green line? This shows that this line is connected through this in every hole is connected each other, as in this line. And you can see these lines are also connected. So first of all, I just use a LED circuit. So for that, I type LED, and you can see, sorry, you can see there are two types of LEDs, and other components are available. Just use these things. You will learn these things later. I am using this LED. Okay. You can see there's two terminals, and one is an anode and other one is cathode. This is little bit bigger. So when we select this LED or any other components, there is a property menu here. This is this one is, you can see we can name these components, and we can select the color of this LED. I'm choosing blue. So I need to place this in breadboard. So I can just click and drag this thing and put it in two holes. So LED, we can use this menu. There is function called rotate. You can use R in keyboard. When we press this, it's rotating, I think in 30 degrees like this. So you can rotate these things and flip these elements. You can see when we press flip button, and it is so first let me drag some batteries, and here you can see batteries, and you can search these things. So also battery, there is available three types of batteries: 9 volt, 1.5, and a cell battery. I am using 1.5 batteries. As I mentioned earlier, when we select a component, there is a menu, a name in here, how many batteries we need. Just select 3 batteries, and the type of the battery can be selected using this menu, or AA or AAA, and I'm using AA for this. So this is the basic things of how to let me connect these things. I am connecting the positive side into the positive terminal. You can just click and connect these things. The wires are already coming up. Then I'm using the negative with the negative terminal. Yeah. Then I am going to power this up. For that, I am taking a wire to the anode and I am taking a wire to the cathode. So this is the full circuit that I mentioned. Let me run this. We need to simulate. So for the simulation, there is a button called Start Simulation. So you can press this and you can see there is a light LED is light up, and you can see there is a huge like an explosion mark. Why is that? I mentioned in this in theory section, if we use LED with this type of through this diode, and the LED will burn up. So for that we need to use resistors, and just type resistor. Sorry, we need to stop simulation to do this. Type here resistor, and this is the resistor. So you can change the resistance, and I'm using 330 ohm, and I need to rotate this. So for the rotation, I'm using this button and I am connecting like this. So you can see the connections. For anode is connected to the positive side of the battery, and the cathode is connected via the resistor to the negative side of the battery. So let me start simulation. Can you see the explosion mark is not here? So that means this is a good circuit, and this will work in physical conditions. So to identify these wirings, we can color them up. In here, you can see there is a green or color box. So you can select whatever side and black for the negative side. So if you want to add a node like this, I mean, if you want to bend wires like this, just double click on the wire and you will end up with a node. It will automatically align with you. You can see the guidelines. Yeah. This is the simple LED circuit that I mentioned earlier. So I think you got the idea about this. And if you want to add some nodes or like that, you can just click this icon, node tool. So if I need to add node here, click the node tool and add the node. So if you want to delete anything, I forgot to mention that it's common thing. If you want to delete any connection or component, just select and press delete icon. It will end up with this. So as well as we can choose the wire type. In here, there are 4 types of wirings available. Most of we can use this normal type, and I'm using, and there are crocodile clips available. Yeah, you can see this. This is with So you need to change the wire type. And the color. So that is the steps of building simple circuit. And you can see in the right side there's a component called basics, and you can use Arduino when we select all. So sorry. Yeah, when you select Arduino, you can see there are already built up circuits in here. You can just click and drag them into your workspace. Am I audible? Is there any connection issue?
No, you are mostly audible. No problems.
Can someone confirm?
Can you hear me?
We can hear you, Anjali.
Okay. In that case, perhaps there is a connection issue.
Okay.
Okay.
So I'm
I think there might be a slight lag, but you're audible.
as I mentioned earlier, as I mentioned earlier, we can use built-in circuits in this. Okay. If you put a code when you use, so there is a function called this is a code edit.
It seems our speaker has encountered a slight technical difficulty. Please hang on for a few minutes.
Can you hear me? Sorry for the interrupt, a little bit connection issue.
Yes, we can hear you.
Yeah, can you allow me to share the screen? Yeah.
Yes. Okay.
So I'm talking about the coding part of the Tinkercad. So if you are using Arduino, or you can use microbit as well, you can code this microcontrollers in here. So this is there is a button called code. Just click it and you will end up with this. This is they provide 3 types of coding. So block coding is most easy one that you can try this, and text coding is the most familiar. I think you have familiar with this. if you work with Arduino. So you can just code these things in here. So we will cover these things in our next sessions. Yeah. And you can try these things, adding different components, making different circuits in here. Start simulation. There are a lot of components available in this platform, so you can use these components to build your circuits. So I think my slide is visible. Let's talk about resistors. I think you saw that I used resistors and changed the resistance value in Tinkercad. So I think you have familiarized with this type of resistors. There are commercially available resistors in our context. So the resistance value is not mentioned in these resistors. So in text. So you have to read the resistance value using these color strips. So I will explain how to read the resistance value of these resistors. There are I think two or three types of resistors. There are four strip, 5 strip, or 6 strip. Most commonly available one is 4 strip resistors. So I will explain this using this type of resistor. The first strip says the first digit, and the same as the second strip, and this third strip is the multiply. I will explain this with example. And the fourth is the tolerance value. Tolerance is the like if this mentioned this is a 1 kilo ohm resistor, there is a little bit ups and down in the value, like 998 ohms or 1002 resistance maybe in this type of resistors. So the tolerance value is mentioned in the last step. So let me explain a little bit. This is the chart we are using. This is you can get this chart in internet. Just type resistor color code and you will end up these charts. Yeah, the green, I am reading the resistance value of this resistor. The green line says 5 and the blue line says 6, and the first two digits of the resistance value is 5 and 6. So third line says the multiplier. The multiplier is orange. That means 1 kilo. 1K. That means 56 multiplied by 1000. That means 56 kilo ohm is the resistance value of this resistor. Excuse me for a moment. Sorry for the interruption. So I was talking about the resistance value, and the last strip says the tolerance value of the resistor, and you can calculate the 2% of the 56 kilo and add and subtract from these values. So that is the about all about resistors. Yeah, this is the end of today's session of our theory session. So if you have any questions, go to the slide. Yeah, the link is in chat, I think. Yeah. Slido and put your questions, and we will answer you. And thank you for this listening, and have a good day. Bye.
A big thank you to our guest speakers for that eye-opening session. Now we'd like to open the floor for some questions. There are already a couple in the link, so I'll read those out first. But in the meantime, if any occurred to you just now, feel free to either put it in the link, or later after I have read these questions, you can raise your hand and ask them verbally. So our first question is, our participants are curious as to whether they can build simple projects after this webinar. So
Yes, am I audible?
yes, you are.
To put it simply, yes, you will be able to build simple robots, as I showed earlier. So you can build like obstacle avoidance robots and like that. So keep in mind that always this is just about the foundation. So you have to build up your theory knowledge on this foundation to be able to make a good project, like a big project. But for simple projects, yes, you will be able to.
Thank you. Our second question is, will these tools and knowledge be related to BattleBots?
Yes. So BattleBots is another area in robotics. So it's a special area in robotics. So as I mentioned earlier, this will be only a foundation. So this is related to every side of the robotics. So if you want to build a BattleBot, or if you want to build a obstacle avoidance robot, or if you want to build a line following robot, this theory will come in handy. So like you will get a knowledge how to choose a battery, choose sensors like that. So from that, how to build the robot, that specialized robot, then how to code that robot, that kind of stuff you have to learn through self-learning, so through internet or other means.
Thank you. There's one more question on the Slido link, and that is, will there be an opportunity to join the circuit breakers?
So you are always welcome to join our community. So that was, I think, put up in the chat. So you can always join our community and put up any questions you have, and answer any questions others put. So, but I think currently we are not recruiting, I think. So that's, I can't confirm that, but I believe currently we are not recruiting. But you are always welcome to join our community.
Apologies. Thank you. So those are the questions we had on the link. Now, if anyone would like to verbally ask a question, you can raise your hand and our team will unmute you so that you can ask the question. And I believe we have one person.
Can I know from where can we get 2K resistor?
I think 2K resistors are not available in market, so you can use two 1K resistors in series. So I think you have this knowledge. If you add two to 1K resistors in series, you will end up with resistance of 2 kilo.
Thank you, sir.
Okay, we have another question from the website. So to read it out, what is the future potential of robotics in Sri Lanka? Why aren't there many companies like other IT sector companies regarding robotics?
IT is a big field, so like it has so much demand. So it's natural that that much of IT companies are existing in Sri Lanka. So there are some companies like as I showed you earlier, Arimac has built a humanoid robot, and also in robotics related projects are done in several companies such as Vega. So you have the potential, and you have to know the right path to choose. So like to add to that, there are so many companies that that research in robotics. So it's not entirely about robotics. It researches that side. So you might be able to find the opportunity there.
Thank you. Are there any other questions? If you want to ask a question, you can raise your hand virtually. Okay, I think it looks like we are done with the question and answer session. So thank you very much for answering our participants' questions. Now that we're at the end of our question and answer session, it is now time to test what you learned today. And to do so, we will be using Kahoot. For those of you who are new to Kahoot, it's an online multiple choice question game that you can join by clicking in the link that will be shared in the chat. Give yourself a nickname and wait for the game to start. After it does, you will have a limited amount of time to answer the questions that pop up on the screen, and you will get points based on your accuracy and speed. So go on ahead and join the link, and we'll give you a couple of minutes to do so as soon as it's shared. Give us a minute to share the link. There we go. The link is up, so go ahead, click on it, join, and give yourself a nickname. I think there's a small issue with the player limit. Give us a minute to fix that. Okay, I am really sorry, but there seems to be a bit of an issue with the Kahoot instance, so we'll have to skip that for today, but tomorrow we will definitely go ahead with Kahoot. So with our knowledge amassing section of the event over, let me take this opportunity to thank Chamindu Lianage and Duvishka Kavin for humbly accepting our invitation despite their busy schedules and for sharing with us invaluable knowledge on the topic of robotics. Please accept this digital token of appreciation for your contribution towards making this event a memorable one. Next up, this is for the participants. Please do fill in the feedback form of the event, which we have already shared on the chat, because your feedback helps us tremendously to improve in our future events. We will also give a certificate of participation to those who participate in all 4 days. And to this end, the feedback form will be what's taken into account when issuing the certificate. So do make sure to go ahead and fill it. I would like to remind you to attend our next session that's happening tomorrow, which will be the second day of the workshop series. Now, I would like to invite all our participants and our speakers to turn on your cameras. Let's snap a quick group photo. I'll give you a couple of minutes to turn on the camera. Nice, we're seeing a few faces. Everyone else, do go ahead. Okay, so I think we can take the picture now. Everyone smile. Thank you, everyone, for joining us in this picture. We have reached the end of this informative webinar. Therefore, I'd now like to take the time to put our gratitude into words. I would like to once again thank our guest speakers, Chamindu Lianage and Duvishka Kavin, for delivering a great session. A heartfelt congratulations goes out to the organizing committee and the volunteers for all their hard work, which made this webinar a memorable one for us all. Next, our participants, without whom this session would not have been a success. Thank you for your enthusiasm and for staying with us, regardless of any inconveniences caused. On behalf of the organizing committee, I must also wholeheartedly thank the Student Activities Committee for guiding and working closely with us on this journey to make this webinar successful. Lastly, Stay tuned on our social media platforms to get frequent updates on IEEE Techverse Sri Lanka and the IEEE Robotics and Automation Society of Wellassa University, as well as Circuit Breakers Robotics. Visit us on Facebook, LinkedIn, Instagram, and YouTube for more events and updates. Thank you. Have a pleasant evening.